Hey Bengals, it's Mrs. Hygic again, and we are beginning our OCW unit. OCW stands for Oceans, Climate, and Weather. Here we go. Your OCW matrix was passed out in class. If you take a look at it, you'll see that our objective today is to recognize that the sun provides energy that drives convection within the atmosphere and ocean, so within the air and within the water on Earth, producing winds and ocean currents. The essential questions that you will be answering on today's WICS is, where does all energy on Earth come from? So where does it originate from? Do all locations on Earth receive the same amount of heat from the sun? And explain. And explain and illustrate the process of convection. So here we go. Earth's energy originates from the sun. All energy on Earth originates from the sun. It drives many different cycles like the water cycle. It drives photosynthesis. It is what is the driving force behind our weather and our climate. But this heating of the Earth from the sun is very uneven, and your latitude, which is your distance away from the equator, affects how much energy your location is going to receive from the sun. So let's take a look here. We're going to start in our red box. Locations near the Earth's equator receives much more direct sunlight, which will create warmer air temperatures and warmer water temperatures. And you can see right here, because the sun is more directly hitting the equator, areas around the equator will be much hotter. The water around the equator will be hotter, and the air around the equator will be hotter. Now, as you move farther from the equator north or south, the sunlight is going to become more spread out because of the curve of the Earth's surface. And this is going to create slightly cooler temperatures, slightly cooler water and slightly cooler air. As we get up into the poles here around the North Pole and down here around the Southern Pole, the Earth is going to be coolest because it is receiving the least amount of heat energy. All of the energy that is striking the Earth in these locations, because of the angle, is much more spread out, and so it's not as concentrated. Therefore, the water and the air around the poles will be much, much colder. So how does temperature affect the water and the air? Well, temperature is really, really important in the density of water and the density of air. When air is cold, the particles, the matter that makes up that air, is going to be moving much more slowly. It's going to have a lower kinetic energy. Therefore, the same amount of particles will take up a lot less space. So they'll have the same mass, but in a smaller volume will equal a greater density. So cool air and cool water is going to be more dense. Warm air and warm water is the opposite. When air and water particles are hot, the kinetic energy is going to be much higher. The particles are going to be moving much faster. So the matter, the mass, inside that volume is going to be moving around, and so the volume is going to expand because of the faster movement of the matter, and so the larger volume is going to cause the density to go down. So cold air and water is more dense, warm air and water is less dense, and we'll talk about what that results in just a second. But first, let's review the three different ways that heat is transferred from one object to another. The first way is through radiation, and radiation is the transfer of heat through space. And so that is the way the heat from the sun travels to the Earth. It travels through space, it radiates through space, and eventually strikes the Earth's surface. And then there's conduction. Conduction is the transfer of heat through direct touch. So if I pick up my coffee cup, then the warm coffee is that heat is going to transfer to my hands through direct contact or through direct touch, and that is the transfer of heat through conduction. So whenever you touch something warm, that is conduction, heat transfer. And then the third way heat is transferred is through convection, and that is the movement or transfer of heat through currents. And this is going to be the heat transfer that we're going to focus on for our ocean climate and weather unit. So let's talk about the convection model. Convection is the process of warm fluids. Fluid can be any air, like the ocean, or water, air like the atmosphere, or water like in the ocean rising. Remember a few slides back when we talked about warm temperatures will cause the density to decrease. Well, that decrease in density will cause that air and water to rise up. And then as it rises up, it will cool off. And once the temperature begins to cool off, the density will become greater. And then that air or water will sink back down. And what we end up with is a cycle, a circular cycle called convection. And this convection is the result of uneven radiation or uneven heating of the earth from the sun. And here is a picture of a convection model. You can see the heat source down here. And so the heat source again for the earth is the sun. And the areas like the equator that receives a whole lot of heat from the sun, the air and the water around the equator is going to get very hot. And then that air and water is going to rise up and cool off and become more dense and sink back down. And then it's going to be warmed up again and become less dense and rise up and cool off and become more dense and sink back down. So this would be like ocean water around the equator that gets very warm, moves up towards the North Pole or even down towards the Southern Pole, cools off, and then comes back down towards the equator. So you have these really huge global, the size of the whole Earth, convection currents of water in the ocean moving up from the equator towards the poles, cooling off and coming back down towards the equator. So the two examples of convection that we're going to be talking about in this unit is convection in the atmosphere and convection in the oceans. And so here you can see land and sea breezes. This is a sea breeze, which occurs during the day. We're going to talk more in detail about this as the days go by. But during the day, the air above the land is warm, and so that warm air will rise up. It will move out towards the ocean where it will cool off, and it will become more dense and sink back down, and then it will blow in back towards the land. We call this a sea breeze because the air is moving from the seaside. And so that happens during the day. Now at nighttime, the air above the land is cooler. And so that cooler air sinks down, goes out over the water where it warms up, becomes less dense, rises up. And you have a reverse in the convection current direction. And so we call this a land breeze because now the air is moving from the land out over the sea. And so we get these winds that are formed as a result of the convection. And then here we'll be talking about convection in the oceans, again primarily around the equator. Notice that the ocean currents are warm, and those warm currents will rise up towards the poles where they will become cooler and more dense and sink back down towards the equator. And in the southern hemisphere, the warm water goes down towards the South Pole where it will cool off and then come back up towards the equator. Now, do notice the direction of the rotation of these ocean currents. In the northern hemisphere, the rotation direction is clockwise. So the warm air goes up and then the cool air comes down in a clockwise direction. Whereas in the southern hemisphere, this convection current direction is the opposite, it is counterclockwise. So the warm air sinks down, warm water sinks down, and the cool water comes back up towards the equator in a counterclockwise direction. And this is called the Coriolis effect. And again, we'll be talking more about that as the days progress. For right now, make sure you answered all your essential questions in on your matrix into your Wix, and I'll see you in class. I'm out.